Good day to you all, and welcome to the Precision Farming Connection, a program that we introduced into the Connected World series back in 2020. So this is the fourth annual edition. Fast forwarding into next year, we will be looking to expand on this with a biannual agenda, reflective of the growing complexity of the global agricultural environment. We are also keen to explore more thoroughly, and in addition to crop monitoring, livestock and fisheries welfare and management, all of which are areas that we have touched on in previous iterations of this program, and as I say, areas that we intend to expand upon and increase our activity in, and you'll be hearing more about that going forward. So, what are the challenges? Extreme weather events, droughts, floods, violent storms, wildfires, and more, all of which are growing in number and becoming more geographically dispersed. High capital and operational expenditure associated with increasingly sophisticated machinery and management solutions, and a continually expanding world population set to hit 10 billion or thereabouts by mid-century, making food production a major global societal imperative. Now, this is interesting to me at least. Currently, worldwide food production exceeds 2,750 calories per capita per day. The average adult across both genders requires 2,250 calories per day, with the average woman requiring 2,000 and the average male 2,500. Younger age groups, of course, require less. So the point is, we are already producing more than enough to provide every human being with certainly an adequate, if not excessive, calorie intake. The challenge is establishing a viable economic model to enable food production where it's needed. And if we can't do that, to establish a distribution network to get it there. And I appreciate that this is another subject, but just the same worth a mention as an integral component of this overall conundrum. So, precision farming, what is it? And now it took a few revisions to finalize this paragraph, but I think I've managed to put a pretty good wrap on it. Precision farming, or farming 3.0, is an agricultural operational strategy and support system which leverages new age technologies in both crop and livestock management scenarios, which can generate data that informs critical decision making and enhances predictive capability, resulting in improved and increased food production through reduced waste of valuable resources and significantly enhanced operational efficiencies, and the enablement of a robust, sustainable agricultural production model. Now, we've previously talked about exponentially rising data volumes being generated, not just in the agricultural space, but across pretty much all industries, certainly the ones that we cover, as we advance into an ever more automated, software-driven and IoT networked future. Today, we're going to be hearing a lot about exactly what data is being generated in the precision farming context, and how the tools that generate it have to integrate and interoperate across multiple platforms to produce meaningful outcomes that maximize its impact. Both Syngenta and VADA are providing unique insights in this respect. And we also have BASF giving us a forward look at how data processing will evolve between now and the end of the decade. All of that is great, but of course, it all depends on connectivity. And with farming operations almost always located in remote rural areas, multi-Earth orbit satellite play deployed in converged hybrid scenarios with 5G, LTE, and other terrestrial communications technologies and media in an overall TMT megamix is the only feasible way to achieve this. And today, we have two of the space industry's super heavyweights in Intelsat and ST Engineering iDirect, who for as long as I can remember have been working miracles in connecting that which is seemingly unconnectable, whether it's a boat, a plane, a train, rural locations with impossible terrain, or in this particular context, remote farming operations, which in places like China, Brazil, Australia, and the USA are often huge. They'll figure out some way to do it. So it's great to have them involved and to hear what they have to say. It's also a unique pleasure to see major SATCOMs players on the same program as key actors within the industries that they are configuring themselves to impact, because it is that bringing together of multi-sector expertise and diversity that characterizes everything that we set out to achieve when we launched the Connected World Series back in 2020. So let's move into the program. Okay, now first up we have Jean-Michel Rouylou. Jean-Michel is head of enterprise and broadband at ST Engineering iDirect with a focus on multiple sectors. Previously, Jean-Michel spent 3 years at ITC Global as the executive VP for the maritime market, establishing a maritime KU band network. He also spent 2 decades at Schlumberger in various roles, including head of VSAT services in Aberdeen. So Jean-Michel will be talking to us about IoT over satellite solutions, enabling smart agro-tech. Now, give me 2 seconds to get the presentation up. And Jean-Michel, over to you.
Well, if we start by the last slide, Paul, it's going to be fast.
We're not done.
Thank you, Paul. Thank you for the introduction, and thank you for setting up this presentation and this stage for us to talk about precision farming. I think you have highlighted the key driver of this, the need for this connectivity needs and the needs for the precision farming. What I'm going to do is briefly restate some of the problems that the farming industry have, the way they address it, and where and how connectivity tools and satellite will fit in there. So I think the first thing, so what are the problems that we are trying to solve? And I'm not a farmer, I'm not an expert, so I'm going to go fairly quickly on that. But basically, these are the problems that farmers have had for centuries. It's keeping an inventory of the crop. Where do they? Where are they? How big are they? And what kind of crops they are growing? They also have to better understand and optimize the fertilization program. I mean, we have seen lately that due to some unsavory events in Europe, some of the fertilization and some of the fertilizer has increased in price significantly. So better using them and targeting the use of those is a key component of the economy for farming. Also, the crops are fairly fragile system, so it's very important to keep an eye of what's going on and how to make sure that they don't have any disease or problems with local wildlife. The more and more governments and institutions are asking for the quality of the food, make sure that the food is properly handled and capable of being consumed by human beings. So there is more and more product certification, more and more compliance. If the farmer wants to do organic product, it's even more complex. So once again, this is an area where the precision farming will help. One other point that Paul touched on is the security and safety. I mean, it's not news for anyone that the wildfire activity has increased dramatically lately. So being able to preview, I mean, or preempt the beginning of a wildfire activity, so to first send the firemen to try to stop it before, or prepare the farm and the stock, all the system that the farmer may have and protect them and put them into a safe area. It's also very important. And last, because those wildfire doesn't come from nowhere, they are coming because there is less and less water. So irrigation is becoming more and more important. So being able to understand what the soil is made of is critical. So this is, in a nutshell, the problem that we are trying to solve. And then the way to solve it is what precision farming terminology is what we call networked farm. And the networked farm is not only the tractors, it's not only a couple of sensors looking at the soil or measuring the temperatures. It's a lot of things. It includes intelligent silos that can monitor real time the contents, the product in storage. It's a drone that can do field mapping and check how the crop are doing. We will see more and more robots or fully automated machine, and I have a use case on that. And then for some people that are in the SATCOM industry, you may have seen John Deere RFP that is extremely ambitious in that direction. Okay, they really want to automate most of their machinery. So the other part is the satellite and mobile radio antenna. That is the way to collect, to gather and aggregate all the data that is collected in the field and pass it to a place where they are going to be processed and be able to be used by automated machine. And last, the analysis platform merge the data with other information that are available, like weathers, like statistics, and be able to tell the farmers what to do and where to do it on his crops and livestock. One thing that we are also starting to see that is not in that slide is more and more all those technology, the intelligent silo, the drone, the robot, are using artificial intelligence, and it's also going to be an important component of that. So what is where is the value, the IoT value chain standing here? So we mentioned farm automation, autonomous vehicles, IoT and telemetry. So what you see is that all those data that are collected are usually kind of stored locally initially, because it's for automated vehicles, for example, latency is critical factor. So being able to process some of the data, not necessarily all of it, but the key one locally is also very important. But once you have done that, you still need to have a place where you can store all those data from multiple farms, as Paul mentioned, some farms in countries are very, very big. So you have to collect all those data from those locations and move it to a central location, most likely on the cloud, and start to apply all the algorithm that can help you and process those data and make it more intelligible and more useful to the farmer. So it's where satellite kind of fits, because these locations are usually remote. In some cases, if you are tracking livestock, they move around. And satellite has demonstrated in the past that they can also do either fixed or mobile or automated assets, like we are seeing more and more in the aero industry. Some drones are completely controlled by satellite, or even more and more in maritime now, where we see fully automated boats. So that's the value, the IoT value chain. And then what does that do? So that's that collect data from various environments. So first of all, I mentioned earlier environment monitoring. So it's very important to know how is the moisture, the pH level. So all of those information is helping the farmer to decide if he has to put more water, or if he has to put a different type of fertilizers, and also make sure that he use only what is good enough. Okay, not only we have to grow more and more crops, but unfortunately we have to grow more and more crops with less and less resources. So and these resources getting more and more expensive. So it's very critical to be very efficient in the way we use those resources. And one way to be extremely efficient is automation, by automating not only the irrigation system, but the treatments and the fertilizer. So we can also help the farmer be extremely efficient and making sure that he use only the bare minimum to produce the level of crop that is expected from the industry, from the world. Another thing is that we all know that farming work is not exactly easy. It's very demanding in terms of times, in terms of availability, not much flexibility. I mean, it's you cannot just take a vacation the day you want, because if the crops is ready to be harvest, then there is no way you can go on vacation. So that's why you see more and more farm machinery that are autonomous, that can be used themselves, and kind of give a little bit more freedom to the farmers in their lifestyle. And all of that, as I mentioned earlier, is through connected farms. And the connected farms usually they may use for local coverage, LoRaWAN. They may use private LTE. In some cases, they may even use Wi-Fi within the barns and within the farms area. But at the end of the day, they need to get those data somewhere else, and then somewhere else is where it's going to be processed, and that's where VSAT has a role to play, as we think has a very important role to play. So now let's look at three use cases. I'm not going to go into much detail of that, but this is something that is happening today, on which we as ST Engineering have been involved. One is a coffee plantation. We have been using Earth observation and do some imagery of the coffee plantation. And through the processing of those Earth image, we are able to predict in a very accurate way the level of NPK that the farmer has to use. And each plant, in each circle that you see here, he can decide what kind of fertilizer to use, when to use it, and which quantity. So by doing so, it's improved his cost, because it reduced the use of fertilizer. It's improved the quality of his coffee as well. The less fertilizer, the better. And it's also prevent the excessive use of fertilizer that may be good for the crop, but not necessarily for all the wildlife that is around. So it's an interesting application, and it's been deployed in Indonesia as we speak. Another example that we are working on with one of our customers in Latin America is early wildfire detection. Here we have the plan of implementing thousands of sensors connected to a LoRa network and then to a VSAT gateway. And these sensors will collect data about temperature, wind, smokes, and this kind of information, and be able to pinpoint an area where a fire is starting, and then dispatch the fighter at the right time and before the fire become uncontrollable. So that's also very important for farmers, because we can let them know that there is something going on, and they can take some action on preventing their livestock or moving their livestock or some of their equipment into a safe area. So it's in a way, rather than waiting like on the picture to see the flames and the smokes, tell the farmer well before that these things are visible, that either the fire has been stopped, or there is a fire that is difficult to stop and it's coming their way. So that's something we are doing today in Latin America. And the last is more linked to what John Deere RFP was about, which is they are doing it today, mainly using LTE and radio, and it's unmanned tractors and harvesters. As you can see on the picture, those two big harvester machines have nobody inside. They are fully automated. And so the precision that they get from that, and the fact that they can have those two machines operating side by side and turning on very complex, as you see on the drawing, complex paths without any accident, would be a fairly challenge for human-driven machines. So you see that it's improved it's improved the flexibility, it's improved the efficiency of the farming machine, but it's also reduced risk. Okay. Now, if the two machines have a problem and they hit themselves, there is no human being involved. So yes, there will be a lot of damage on the machine, but at least no lives will be lost. So these give you an example of how wide and how diversified the application can be, from growing coffee, detecting wildfire, or driving big machine. So that's what is, precision farming. It's capable of handling all those needs and trying to come out with a single standardized answer. We are not there yet, but that's what we are working on. So how do we help this fairly new industry or new segment achieving those goals? But first of all, because in VSAT, we have a lot of experience in VSAT, and my colleague from for people from Intelsat will tell you that they have been doing that for decades. iDirect as well. So it's something. It's a technology that we know well. It's also a technology that is extremely reliable. In some cases, in some place, it's even more reliable, like fiber connectivity. Once the satellite is up there, there is very little thing that can happen to it. And it's also capable of doing very, very low data rate or very high data rate. So it can either collect the data from the sensor, it's a low data rate, or it can collect the data that are already gathered or pre-processed, which could be huge volume, and send it to the cloud. It has different type of technology in terms of terminal. Some of them are flat panel antenna that are extremely easy to deploy. And this antenna, this terminal, not only come with the satellite protocol, if you want, which most of the time are proprietary, but also with standard protocol like Bluetooth, Wi-Fi, and LoRa, for example, and in the future NB-IoT. And for the high data rate, we are capable of achieving 1.6 gigabyte on some cruise vessel. I'm not sure the farming industry will need that kind of rate anytime soon, but the technology is here, and so that means it's not going to be a bottleneck in terms of data rate. It's also extremely flexible. It can be easily deployed and quickly deployed, and because it's an industry that has been around for a long time, the capital investment is not necessarily very high, and the technology is extremely well understood, and a lot of people are capable of deploying those kind of equipment very easily. And so, in a nutshell, what ST Engineering is doing is taking all the knowledge, all the expertise he has developed for the maritime industry, on the fixed VSAT for the oil and gas, for the mining, and applying to the farm. And all the, at the end of the day, data is data, okay? That is come from a sensor measuring moisture in the soil, or a sensor measuring the pressure of the oil in the pipe, is the same. It's a data. And so the technology that we have been using for years to transmit the data to central data center, it can be used for the industry, for the farming industry. So if we look at it in the whole picture, if you want, it's basically, you have sensor in the field, you mix that with drone imagery, you do I took the example of fluoride, it could be any type of data aggregation, put the VSAT connectivity in between, and send all of that to artificial intelligence analytic platform in order to process this enormous amount of data that has been collected by the sensor, and provide a sensible and usable and actionable information to the farmer. And that is my last slide.